Hi, today we're going to be having a look at quantum theory, and specifically I'll be walking you through what a black body is, the problems with the black body including UV catastrophe, birth of the quantum theory as stated by Planck, the photoelectric effect, and then Einstein's contribution to the quantum theory as he applied the quantum theory to explain the photoelectric effect. Starting off with the black body. Essentially, a black body is an object that absorbs all the radiation that falls on it. Since no radiation passes through or is reflected, it appears black. Eventually what will happen though is a black body, after it's been absorbing all this radiation, it will start giving back some of this radiation. And as it emits this radiation, we get a radiation curve. Now, black bodies were known and understood in the late 1900s. However, there wasn't that much experimental data, and as the experimental data started coming through, it sort of contradicted with the classical theory. One of the problems that they had was this thing called UV catastrophe. Now, essentially what that was this. According to the classical theory, if we draw the curve of a black body, then it should look like this. On the y-axis, I actually have the intensity, and on the x-axis, I actually have the wavelength. According to classical theory, in which energy is absorbed or emitted as a continuous stream, the graph would look something like this. As the wavelength got smaller, the intensity increased exponentially, which led to UV catastrophe, because as the wavelength goes towards UV light, you get a large amount or highly intense radiation coming out. However, as they started doing the experiments, according to the experimental data, the graph looked more like this. There was a different peak for a different temperature. So let's just say that's 5,000 Kelvin. So you'll have a peak over here. A black body at a different temperature would give a smaller peak. So this would be something like 4,000 Kelvin. So this is what they were getting from the experimental data. Now, the quantum theory in itself was proposed by Planck. Now, in relativity, what happened was Einstein was the person who solely came up with relativity. Quantum theory, on the other hand, even though it was proposed by Planck, Planck did not believe in it 100%, and he was kind of hoping that someone else would come up with a better explanation. And over time, other people like Einstein and Heisenberg, they all added to the quantum theory. Now, the birth of the quantum theory, as I said, was by Planck, and what Planck was trying to do was, he was attempting to explain the reason that the radiation from a glowing object changes in color from red to orange and finally to blue as its temperature changes. So if I take a black body and I heat it up, the temperature, if the temperature is low, it will be red. As I increase the temperature, it goes to white, and as I increase the temperature further, it could possibly go to blue. And this is what Planck was trying to explain. And classical theory could not explain this, and the answer was found by making a small assumption that energy, like matter, existed as discrete individual units rather than just a constant electromagnetic wave. So rather than energy being continuous, it was now in packets. This is the quantum theory. Now, the quantum theory could also be used to explain the black body radiation curve, and as I said, although Planck came up with this, Planck wasn't very comfortable with this, and he was actually hoping that someone else would come up with a better explanation. However, in 1905, Einstein actually used the quantum theory to explain the photoelectric effect, and this was the basis after which quantum theory started getting more acceptance, and then other people started using it and adding on to it, and we have the quantum theory as we have today. So the photoelectric effect was another principle that really could not be explained via classical physics. What is the photoelectric effect? Stated simply, all that the photoelectric effect is the emission of electrons from matter after the absorption of energy from electromagnetic radiation such as light. So if I have a matter, it absorbs EM radiation. such as light, what it does is it emits electrons. I shine light and I get electrons. That is the photoelectric effect. The classical theory of light, in which light was considered to be a wave, could not actually explain all the effects of the photoelectric principle. So Einstein actually said that light